here we go. So, as Federico and Anastasia already said, you should tweet about this event, because it's a great event, and then everything's being recorded, so let people know which talks you liked, which talks you didn't like, so maybe mine. And then so people can rewatch the recordings and maybe show up next year here. So who am I? My name is Chris. I'm not wearing my Twitter shirt today. I thought I'll switch it up a little bit. I work for Twitter, right? So I started to work for Twitter about 3.5 years ago, and I'm working in the VM team. So we have a VM team that works on the JVM, and in particular, I'm a compiler engineer, right? That's what I'm doing for more than 15 years now. So if we're going into the Oxford Dictionary and ask, so what's a compiler? It's a person who produces a list or book by assembling information or written material collected from other sources. That's not what I do, right? But there's a second definition, and that's what I do. A program that converts instructions into machine code or lower level form so that they can be read and executed by a computer. That's exactly what I do. And in particular, I'm working on something called optimizing compilers. There are many types of compilers, right? You might know Java C or Scala C. These are source compilers, compiling source code into, let's say, Java bytecode. I'm working on optimizing compilers that actually produce machine code. And you can see common requirements for optimizing compilers are to minimize a program's execution time, sure. Memory requirements, everyone cares about that. And power consumption, right? That's important. And especially the last two being popular for portable computers, absolutely true. You want your laptop to run as long as it can. You want your phone to run as long as it can on the battery it has. But in today's world, the last two also become very important in data centers. And this is what this talks about. So in general, I'm very focused on performance, because that's what I do. That's my compiler background. But today, I want to talk more about performance and our impact. What impact does our industry have on the world? So how does software development work today? Probably you guys know better than I do, because my work is slightly different than you do. I actually had to look up what a sprint is. I'm sure every one of you knows what it is, so I had to ask Atlassian, what is it really? So sprints are the very heart of Scrum. I have no idea what Scrum is. Agile methodologies and getting sprints right will help your Agile team ship better software with fewer headaches. Is it true? I don't know. It also, the page also says this: Sprint makes projects more manageable, sure, allow teams to ship high-quality work faster and more frequently, and gives them more flexibility to adapt to change. Is that true? I'm worried about these. Faster and more frequently. It sounds to me that only applies to features, right? You kick the features out the door as quickly as you can, faster and more frequently. Does that mean it's high-quality work? I don't know. So there's a story I heard when I joined Twitter. It's unfortunately a true story. Luckily, I don't know which team it was. So someone told me a team inside of Twitter, one of the services, they had problems with memory. So they were using too much memory and too much GC pressure. They had too many GCs. So basically what they decided to do was, I think 3 engineers sat down for about 3 weeks and decided to get rid of all the memory allocations that they could see they could get rid of. So they worked on this for 3 weeks. They got some things done, and they were super excited about the work they did. But how much do you think, at the end, how much improvement or how much memory allocation could they reduce? Exactly, 0. So all this work was for nothing because the compiler already took care of that, right? So there's something called escape analysis. You can read it up on Wikipedia if you want. It's basically getting rid of all the object allocations that the compiler can prove you don't need, which is basically what you would do as a human as well. So the point here is you should know your compiler optimizations, and I always say don't be too smart. So when people ask me, I used to work at Sun and Oracle on Java, the platform, and a lot of people, when I'm at conferences, ask me, so, because I work on the JVM and I work on compilers, how should I write my code so that the JVM can optimize it the best? And my answer is always, write it as it's supposed to be. And the reason for this is because the compiler is not, it doesn't have an AI. It's not a thing that it can think. A compiler is a pattern matching machine. So we expect certain patterns, and we match these patterns and optimize that code. If you're being too smart and bringing in your own patterns and do bit twiddling and stuff, we can't recognize that anymore. So source code is meant to be consumed by humans, right? It should help you to understand what's going on. It should help you to maintain the code and so on. Let the compiler take care of the rest. I'm not going to talk too much about this. I'm actually thinking about preparing a talk. I think there is already 1 or 2 YouTube talks about compiler optimizations. Most of them are listed on this Wikipedia page if you're interested. So data center and electricity usage, that's pretty much what I want to talk about today. So I found this page from Google. It says data centers and machine learning. But like in the text down there, it says that our data centers today use about 2% of the world's electricity. Yeah, it doesn't seem too much, but if you think about it, 2% of everything, it's quite a lot, right? So this chart shows us in our industry, ICT, so information and communication technology, how much electricity we're using. And we are now at 2019 down here, and the green are the data centers. And this is the projection into like what, 10 years, 11. So we're more than tripling or quadrupling, I don't know how much that is, data center electricity usage. So it's something we really should think about. And if you remember, compiler technology means optimizing compilers, reduce power consumption, so it's very important. So the good thing is, if you look at all the big companies, all the big cloud providers, so Google, for example, in 2017 already, they achieved the major milestone of purchasing 100% renewable energy for their data centers. So, you know, they're kind of carbon neutral, but that means if they buy it, it's not being used somewhere else, right? So then I found this tweet the other day. I found that very funny because Google is building a new data center and they're basically offsetting the electricity this data center is using by 2 solar farms, which is perfect, right? Built the data center in the desert. They usually do it in the US in Nevada or whatever, Arizona, where there's a lot of sun. But they built the data center on the site of a coal-fired power plant, which they tore down. I found that very cool. So Amazon, they are trying to be 100% renewable, but they aren't yet. It says AWS exceeded 50% renewable energy usage for 2018. So, I mean, you know, they're using more than they projected, but they are not quite there yet. And as you can also see, they're building these new wind farms and solar farms in Ireland and Sweden and the United States. But at the very bottom, all of the ones they're building, 2.9 gigaterawatt hours is what they're projecting that whatever things they are building will produce. But all of what they are building is for them, right? All the 2.9 terawatt hours will be used by the data centers. And everyone else will use the coal-fired power plants. This I found very interesting. I've never heard of this before. So Microsoft apparently internally has something called a carbon fee. So what that means is if your department at Microsoft is using too much electricity or whatever, computing power, you have to pay $15 per metric ton you're producing out of your own budget, right? So if you're using more compute power, you have to pay more money. And they just doubled that to $15 to incentivize more. The bad is this. That's the overall energy production. Its energy production is slightly more than energy usage, but it's pretty much the same. This is from the International Energy Agency, so I trust their data. And as you can see, we almost doubled since 1990. And the other thing you can see, yeah, sure, at the very top, at the very end, solar, especially wind is coming up. But if we look at this in a percentage range, coal really hasn't changed, right? Yeah, oil changed because I don't know why. Natural gas became more, we all know that. Nuclear went down, sure, hydro is about the same. And then at the very end, we get these new ones, but we're far away from being renewable. So everything we're wasting is basically coal or natural gas. So remember this guy? And it says data centers and machine learning. And there's a link that says read more. And if we click on that one, we get to this page. And I found that page very interesting. Machine learning finds new ways for our data centers to save energy. That's cool. So basically this guy, I forgot his name, in 2014, the Google data centers used already 50% less energy than the industry average. And the way they achieved that is by buying better equipment, just more efficient equipment, which they installed in the data centers. And so the next question was, could they run even leaner? And this guy, Jim Gao, he took an online machine learning class, and he thought, maybe I can apply machine learning to the data center problem. And this is something that might be obvious, but just 10 pieces of equipment in a data center with 10 settings, which is basically nothing, produces already 10 billion different configurations that you could have, right? A human can't do that, but machine learning can solve the problem. And this is what they did. And they reduced 40% energy used for cooling and 15 overall. So just by applying machine learning, I'm not exactly sure what they did, moved equipment around or had different settings for the equipments, they just reduced 15% of the data center electricity usage, which, going back to whatever Amazon said, 2.9 terawatt hours of electricity, 15% of that is quite a lot. And I have a Twitter example. I haven't given this presentation yet here, I think. I'm not sure which one I gave last year, but we do that too. We use machine learning to reduce our CPU utilization, which basically converts into dollars, right, into money. So this is the tweet service, and we're comparing basically C2, that's what everyone's using today, and then on top we use Graal, the compiler, which already gives us an improvement, and this Autotune, the red one, is the machine learning part over the orange one. And so we just reduce, by applying these two technologies, memory allocations for processing one tweet by 7%. It's great, right? You use 7% less memory by doing the same amount of work, which then translates into 7% less GC cycles. And less GC cycles, everyone loves that if you have less GC cycles, because basically what happens then is your latencies go down, right? If you have less GCs, this is what's happening, and it's a little difficult to tell how much improvement that is, but if I integrate it out over the 24 hours, you can see we reduce P99 latencies by 28% by just applying these two technologies. And the Autotune part alone gives us 8, right? And that translates into the actual saving. That translates into 18% of CPU utilization savings, which means we can use 80% fewer machines and less electricity to run the same thing, right? We're a little smarter about how to run it. You might know what that is. Yeah, some people are already laughing. It's a Bitcoin mining farm. And I'm using Bitcoin here for a few examples or points I want to make. So this is the first one. This just tweeted a few days ago. The energy footprint for one Bitcoin transaction today or on September 29th was 606 kilowatt hours. One. So that means it equates, they say, well, it's 20 days for a US household. You can already see the difference between the US and Germany, 63 days, or China, 170, 288 kilograms of CO2 per one transaction. And then you can see how to compare it to. So it's a huge waste of electricity. 78 terawatt hour per year is the current state, which increases every second, right? This is the University of Cambridge has this Cambridge Bitcoin Electricity Consumption Index, and it's actually very interesting because then they compare the current electricity usage per year to the countries, right? And right now we're between Chile and the Philippines. These are the populations of these countries, right? So the Philippines, 100 million people is basically what Bitcoin is wasting every year. And yes, Bitcoin, there are other cryptocurrencies coming up, which means, okay, they use electricity too. Bitcoin is a very computationally intense one. There are some that are cheaper, obviously, but this is what a lot of people still do today. This is outrageous, if you ask me. This is a graph of the energy usage in terawatt hours over the years since January 2016. And there are 3 lines, and they're basically 3 because they don't know what hardware people are using to mine Bitcoins. Right? The bottom one would be the most efficient one, the top one would be the most inefficient one, and in the middle is kind of the average. If you look, I want to look at this part here. You see that? It happened in like end of 2018. Some people might remember that actually. And I want to point that out because the energy consumption of the Bitcoin network dropped from 50 to about 30 terawatt hours. And that's 40% less. What triggered that? Well, it was the Bitcoin price dropped by half, right? So Bitcoin was hovering around the $6,000 for a while, and then it dropped down to 3, which meant it wasn't, they couldn't make money anymore because they had to spend so much energy to produce 1 Bitcoin, and then they didn't pay off anymore. The thing that I find so interesting here is that everything's dictated by money, right? If it's not worth doing it anymore, no one cares. But no one really thinks in the big scale, like you or your companies, how much money you're wasting into the cloud, right? Most people are not on-premise anymore, you're just doing cloud computing, which means it's very easy to get more. If you had your own machines back in the day, in your office, right, you had to go online, buy a machine, get a chip, get it installed, blah, blah, blah. Right now, the only thing you need is a credit card. You go online, buy 1 more. It's so easy to do. This is the cost to mine 1 Bitcoin in all the countries. You probably can't read that. But I took the top 3 and the bottom 3. So Venezuela, $530 to mine 1 Bitcoin. This is basically only depends on the electricity price. Bitcoin right now are around $8,000. So yeah, move to the first 3 if you want to make some money. Don't move to South Korea. Right? No one's probably mining Bitcoins right now in South Korea. I didn't count how many are still below 8,000, but it's probably more than half. So that was the wasteful thing, right? Bitcoin, one guy thought, oh, Bitcoin, that's a fun thing, right? Cryptocurrency, it's cool. In the very beginning, it was very cheap to mine Bitcoins. And then it exploded into that thing it is today. So the lesson here is it's sometimes very difficult to predict the future and see what's going to happen, but sometimes we should think about if we're doing the right thing. So history of Bitcoin mining hardware, that's the other thing that I found interesting about Bitcoin. Because in 2009, people started mining them, and they started mining with multi-core CPUs. That's all we had, right? And then at a rate of 50 per block, which was pretty reasonable, so people did that for fun. One guy, I should have put that in the slides, the first valuation, I'm not sure if it's true, but it's a fun story. The first valuation of a Bitcoin was a guy in a forum said, I'll give you 10,000 Bitcoins to bring me 2 large pizzas. And then they say, well, it would be $8.6 million today, but he ate it. That was 2009. In 2010, the CPUs weren't enough anymore because the complexity to get new Bitcoins increases over time. And 2010, we're already doing it with GPUs because GPUs can do these massively parallel things really, really good. So everyone was doing that, and they're pretty cheap, right? And then already in 2011, like every year, we're moving on to something else because it's getting more and more expensive. They were already building FPGAs because FPGAs do exact one thing really good. And in the same year, they moved away from FPGAs to integrated systems, because that was the only way to actually be profitable and make money off of mining Bitcoins. The interesting thing here is the performance improvement is incredible, right? Today, you couldn't mine a Bitcoin on a multi-core CPU, but it was all, again, dictated by the money. This I found interesting as well. So it's game over for climate change. So gaming industries are jumping on the train. So they're doing things, they're making promises like that we're planting trees or we're using less plastic packaging for our games. Was actually cool. For making game devices more energy efficient. I think that would be interesting, right? Everyone has 1 or 2 or 3 gaming consoles at home. If there would be more energy efficient, that would be cool. To incorporating environmental themes into the games. That's a very interesting thought, to actually not just shoot people, but to actually make games that are a little more environmental conscious and where you learn things about what the hell's going on. His name is David Paul. He's the environment minister of the Marshall Islands. I'm not sure if you know the Marshall Islands, small island archipelago in the South Pacific. The Marshall Islands with the Christmas Islands will be the first islands to disappear. Because what's happening is with the rising sea level, their freshwater table gets poisoned with salt water. All the plants die, they can't drink water anymore. So they're actually already actively being moved away to different places, mostly Fiji. So he says, with an estimate of more than 2 billion video game players globally, this is the most powerful mobilization channel in the world. Yeah, I kind of agree, right? If you have these games that teach you to not be too wasteful with resources, that might make an impact, especially when younger kids are playing it. And then Sony has these plans of the next generation PlayStation with a low-power suspend play mode. I'm not exactly sure what that means, but he said if 1 million players use that, they could save electricity to power 1,000 average US homes. I'm assuming that means a year. I'm not sure. It doesn't. The article didn't say. But that's already a lot, right? We couldn't reduce our power consumption and all of this with all these tiny little things that we can do. Just the Twitter example, we just reduced the power consumption right there. I want to go back to this one real quick. You've seen it before. Well, obviously, we'll be looking at the green, the data center one, but there's another one that's very big, and it's the blue one. And the blue one is networks, wireless and wired, which basically means wireless, obviously, our phones, more and more data will come to our phones, but also other data that we are shuffling around, right? Netflix, YouTube, it's becoming more and more data, more Ks, 4K, 8K, bigger files. So data reduction and caching will be very, very important in the future. And the previous graph was electricity usage for these networks. So I want to use Twitter as an example here. We introduced Twitter Lite a while ago. The reason why I'm giving this example is we basically introduced this for developing countries, right? It was, again, driven by money because in developing worlds, they sometimes only have 2G, and its data is very, very expensive. So we couldn't push all the Twitter data to their clients because it would be way too much money for them. They couldn't afford it. So we introduced that one. And there's also something we introduced in our official client, which is called data saver mode. I'm sure most people don't use it. Even I don't use it. So this is my phone, but I had to turn it on just for the screenshot. Basically what it does, it gives you lower quality images in your timeline, and then when you click on it, it loads the high quality, right? Why do you need high quality in your timeline? It would be just data being transferred to you, and you might not even be interested. Same for high quality video, and the autoplay one, I think, is an important one. If you scroll through your timeline and every video starts playing, really? Does it have to be? Probably not. This, I think, will become very, very important. Content delivery networks. We need to cache data locally so we don't have to transfer it all the time across the globe. I tried to find good graphs for the CDNs. Unfortunately, the big ones, they don't provide a good, not really good data. But this is Google, and it's their data centers. So it doesn't include the CDNs, but it's their data centers. And as you can see, it's very focused basically in 3 areas. It's North America, it's Europe, and then the Asia, Hong Kong, Japan, North Korea, South Korea type of thing. There's only one in South America, right? None in Africa. So all the data we're transferring to Africa has to go through all these networks that use up a lot of electricity. This was Google. This is Amazon. The picture is pretty much the same. Do we actually see the world? That's interesting. I can see it. So imagine. So this is North America, obviously. That's Europe. So they have one in South America. They are trying to build one in Cape Town, in South Africa, and then they have one in Australia. So again, it's very centered to North America and Europe, and the other ones we have to build up. The only one that's better, better. Let's stay on this slide for a while. Microsoft is actually better. So they have a lot in North America, a lot in Europe, one again in South America. They're all in Brazil, so that's the thing to do. They already have today 2 in South Africa, which is great. They have 4 in Australia. All the other ones only had 1. And then the thing I remember, Google, I think, had 90 metropolitan area CDNs. So basically the biggest cities in the world have these CDNs where they cache data locally. Yeah. So the thing I want you to take away from this presentation is performance tuning has an impact. It absolutely does. The question is, with your sprint way of doing things and agile methodologies, do you have time to think about that, right? Or you're constantly being, told to ship that feature today and then work on the next one. Every now and then, I think we all should start pushing back and say, hey, maybe we should think about the things we're doing. So stop every now and then and think about the impact that your work has on the world and on everyone around you. Thank you very much.